Okay, let's dive right into this photographer's guide to one-quarter intensity. Today, we're going to demystify what is probably the absolute most intimidating math behind lighting for beginner and even intermediate content creators. We're talking about the inverse square law. Now, I know just hearing the words law or square might make you want to pack up all your gear and go shoot purely in natural light forever, but stick with me here. We're going to translate this seemingly complex physics concept into a highly practical, everyday tool that will completely change how you approach your photography. So think about your last few shoots for a second. Do you consistently struggle with placing your lights? Have you ever, taken a group photo where the people in the front row look perfectly exposed, but the folks in the back look like they're literally standing in a cave? Or maybe you've tried taking a simple portrait against a white wall, and no matter what you try, the background just keeps turning out this murky, weird gray. Well, if you've ever been frustrated by uneven exposures or blown-out backgrounds, you are definitely not alone. And the culprit behind all of these headaches is exactly what we are going to master today. And hey, if you're feeling a little anxiety about the math part, let me validate that fear with a really fantastic quote from photographer Jeff Geyer. He wrote, "I ditched my briefcase for a camera bag, secure in the knowledge that confusing math had no place in photography." And then the inverse square law reared its ugly head. He totally jokes about how it just waits for you to get comfortable with studio lighting before it strikes. But the reality is, we all deal with light. It is the defining element of capturing an image. So whether you use strobes, speed lights, or just the sun, you really cannot escape this law. So let's talk about the scary lighting math. We're going to tackle this head-on and translate it into a rule you can easily visualize right through your viewfinder. Okay, here is the formal definition from the folks at ProGrade Digital. They state, the intensity of light is inversely proportional to the square of the distance from the light source. Right, that sounds like a ton of academic jargon. But simply put, it just describes how light behaves as it travels through space. As you move away from a light source, the light's intensity diminishes. But it doesn't just slowly, evenly fade away. It actually drops off in a very specific, geometric way. And here is the absolutely crucial point. Moving a light from 1 foot away to 2 feet away doesn't just cut your light power in half. I mean, logically, you'd think doubling the distance equals 50% of the light, right? But in actuality, doubling that distance causes a massive 75% power drop. You are left with exactly 1/4 of the original intensity. That is a 2 full f-stop loss of light, literally just by taking one single step back. And understanding the geometric spread brilliantly illustrates why this happens. Imagine your light is shooting through a 1 by 1 foot square frame placed exactly 1 foot away from the bulb. When you double that distance to 2 feet, that exact same beam of light hasn't just moved backward, it has spread out across 4 squares instead of 1. Because that exact same amount of light is now being diluted over a much wider area, any single point receives only 1/4 of the original power. Now, seeing the physical effect of this over a longer distance reveals something really interesting. The light fall-off is extremely rapid right at first. Moving from distance 1 to distance 2 loses 75% of your light. But notice what happens when you move from distance 3 to distance 4. The math drops from 1/9 intensity to 1/16 intensity. The visual difference becomes incredibly small. So that means the drop-off slows down significantly the further away the light gets from your subject. All right, perfecting single portraits. Let's look at how this 1/4 intensity rule builds into practical application on an actual shoot. We have to compare the extremes to really get this. If you place a light just a few inches away from your subject's face, the fall-off happens rapidly, right across their features. The side of their face closest to the light is brilliantly illuminated, but because of that massive 75% drop, the opposite side of their face falls into deep, dramatic, high-contrast shadow, which, is great for moody, artistic portraits. Conversely, a distant light spreads its energy evenly. Because all that rapid fall-off happened in the empty space between the light and the subject, the light crossing the subject's face is now much more uniform. This gives you a slower fall-off gradient and a beautifully even illuminated portrait. So if you're looking at your monitor and the shadows on your subject's face are just way too harsh, you have a few rapid-fire troubleshooting steps based on this law. You could diffuse the light through a softbox to scatter it. You could introduce a fill light or a reflector to bounce some light back into those dark areas. But honestly, the absolute simplest trick in the book is just to increase the distance. Simply pushing that light stand back a couple of feet reduces the intense gradient, softens the shadows across the face, and gives you a much more flattering, balanced exposure. Okay, lighting groups evenly. Let's scale up what we just learned to solve one of the most common lighting nightmares out there. Imagine you're photographing a large wedding party, or maybe a corporate team. You take the shot, look at the back of your camera, and you ask yourself, Why is the front row glowing and the back row in total darkness? Well, this is a classic inverse square law problem. As the experts at BYU Photo highlight, if you place your light source 1 foot away from the front row, well, that means it's roughly 2 feet away from the second row. You've doubled the distance. That means the second row is automatically receiving 75% less light than the first row. They are 2 full stops darker right off the bat. To fix this, you just have to follow 3 simple steps. First, move the light much further away from the front row. Let's say you move it 10 feet back. Now the front row is 10 feet from the light, and the second row is, say, 11 or 12 feet away. Step 2 is complete. You've equalized the relative distance. Because you are much further down that exponential curve we looked at earlier, the percentage difference in light fall-off between row 1 and row 2 is now just a tiny fraction of a stop. Finally, step 3. Because you move the light back, it's weaker overall, right? So you just must increase the light's output power or open your camera's aperture to compensate for the new distance. And just like that, suddenly everyone in the group is evenly lit. Let's talk about backgrounds and natural light. Next, we're going to explore how this 1/4 intensity rule actually acts as a magic wand for controlling your backdrops and shaping natural sunlight. Look at how meter readings spread out along a wall. The light drops a full stop from f22 to f16 in a matter of mere inches near the source. But further down the wall, it takes several feet to drop just 1 stop. You can totally use this to your advantage. If you place your subject and your light super close to a plain white wall, it's going to blow out perfectly white. But pull them 10 feet away from that wall, and the rapid fall-off means only a tiny fraction of the light actually reaches the wall behind them. It'll photograph as dark gray or even pitch black. It is all about relative distance. And remember, the principles of how light travels absolutely do not change just because your light source doesn't take batteries. This exact same rule applies outdoors and with natural light. As photographer Alistair Curl points out, if you have a subject standing right next to a window, they are bathed in bright, soft light. But if they take just 1 or 2 steps away from that window, boom, the 1/4 intensity rule kicks in. The light drops significantly, the contrast increases, and the background falls into deep shadow. You can completely change the mood of a scene, literally just by having them take a step backward. Now, when the rule fails. Let's transition to a really vital myth-busting section about when this math simply does not apply to your shoot. Because if you misapply the inverse square law here, you are going to end up with wildly incorrect exposures. The entire 1/4 intensity drop relies entirely on one specific condition. The light must be spreading uniformly in all directions, kind of like a sphere. Think of a bare light bulb hanging from a ceiling. The light is exploding outwards in a 360-degree radius. Because it's spreading out so wildly, it loses its density and intensity very, very fast as it travels. But the major exception to this rule is collimated light. When you take a light source and put a Fresnel lens in front of it, or a deep parabolic reflector, or use a laser, you are taking those wild, scattering light rays and forcing them to travel in a straight, parallel line. This creates a highly narrow directional beam. You absolutely have to contrast these 2 types of light in your mind so you know exactly when to trust the math. Omnidirectional light from bare bulbs, umbrellas, or softboxes spreads out, falls off rapidly, and strictly obeys our 1/4 intensity rule. Collimated light, on the other hand, from a spotlight or a Fresnel lens, barely spreads at all. Because the beam doesn't diverge, it doesn't lose its density. The intensity stays relatively constant over much longer distances. If you try to use the inverse square law to calculate the fall-off of a laser pointer or a focused theatrical spotlight, the math will absolutely fail you. So always know what kind of modifier you are putting in front of your bulb. Well, we've covered a lot of ground today, going all the way from the intimidating physics of light to highly practical on-set problem solving. You now know exactly why pushing a light back solves those group photo nightmares, and how pulling a subject away from a wall turns a white background into a black one. So, I leave you with this final exciting challenge. How will you use the 1/4 intensity rule to shape the light on your next shoot? Don't let the math scare you, let it empower you. Grab your camera, grab a single light, and go play with distance. You are going to be amazed at what you can create.